Hey guys, welcome back to lecture series on numerical method. So in my today's videos guys, I'm gonna explain to you all one of the example based on the Jacobi iteration method. So method already I explained in my previous lecture. So if you are interested to see this video, you can check here in I button, or you can go here, in my description box. You will get the video link there. Okay. So without further ado, let's get dive into our today's lecture. First of all, we're gonna see the Jacobi method, what we have learned in our last lecture, and later on we go for finding the solution. Okay. So see that this is the example which asked in December 22, repeated example from your previous year question paper for 5 marks. Okay, so see that guys, it's not difficult. It's one of the easy example that can give us a very easy mark. So take it very carefully. Okay, yes. So let's get start the solution. So what the Jacobi iteration method says that? Jacobi iteration method says that using these three equation, find out the x1, find out the x2, and find out the x3. Okay, so using first equation, find out the x1. Okay, by equations. Okay, so what do we have equations? 20x1 plus x2 minus 2x3 is equal to 17. Okay, so I'm going to find out the x1 first of all, which is equal to 1 divided by 20 under bracket. Okay, 17 minus x2 plus x2 gives us the minus x2, and minus 2x3 it is a plus 2x3. This one is the value for x1. Okay, using our first equation, using only the first equation, you have to find out the x1. Okay, so using second equation, find out the x2. Okay, by using second equation, so x2 can be written as using the second equation. Okay, so 1 to x2, we want the x2 only, so take 1 by 20 to the other side under bracket, minus 18. Okay, minus 18 minus 3x1. Okay, and plus x3. This one is our next equation, value for x2 using second equation. Okay, find out the value for x3 using third equation. Okay, x3 means take this to the other side, so we write 1 upon 20. Okay, 1 upon 20. Okay, under bracket we take 25 minus 2x1 plus 3x2, 3 times x2. Okay, and after that negative sign we have, no, minus 20x3, so take it to the other side, we will get the minus 1 upon 20. Okay, yes. So see that I got the value for x1, I got the value for x2, and I got the value for x3. Okay, this is our first task, to find out the value for x1, x2, x3. Okay, so let's go for iterations. Okay, first iteration, what we do here? So for first iteration, okay, we go for our first iteration. So you can consider x1, x2, x3 and find out x1 to the power 0, x2 to the power 0, x3 to the power 0 as the first iteration. Okay, or first iteration you can consider x1 to the power 1, x2 to the power 1, x3 to the power 1. Anything you can do it, you will get the right equivalent answer. Okay, that means both of the methods are correct. Okay, so in my some of the example I explained as a x2, x3 0 and x1 to the power 0. Okay, as a first iteration. But now you can take this one, or you consider x1 to the power 0 as a first iteration. Okay, yes, initial approximation. Let's consider initial approximation. Let's consider initial approximation. Okay, initial approximation, what it says that consider x1 to the power 0 as a 0, x2 to the power 0 as a 0, and x3 to the power 0 as a 0. Okay, so we have to consider these three value and replace these three value in this equation. Okay, so now see that, so we want the first iteration, that means x1 to the power 1 we want. Okay, x1 to the power 1 is a 1 by 20. So now see that how I am going to write this equation. X1 to the power 1 as 1 by 20 under bracket 17 minus x2 to the power 0 plus 2 times x3 to the power 0 So these x2, x3 are there now, consider their power 0. Okay, so you will get the x1 to the power 1. Again, x2 to the power 1, okay, x2 to the power 1, so which is a 1 by 20 under bracket x3 to the power 0, x2 to the power 0, minus 3 x1 to the power 0, x1 to the power 0 minus 18, bracket complete. Okay, and x3 to the power 1 is a, so now see that guys, this one is a plus 20, I took as a minus 20 here, this one is a plus 20. Okay, so this one is a plus value, so if this one is a plus value, so we get this a plus 1 by 20 here from this side. Okay, and later on x1 to x3 to the power 1, we write 1 by 20 under bracket 25 minus 2 times x1 to the power 0 plus 3 times x2 to the power 0. Okay, bracket complete. Now see that these are the first initial approximation, x1 to the power 1, x2 to the power 1, x3 to the power 1. Okay, using given equation inequalities I written this one. Okay, now I consider x1 to the power 0 as a 0, x2 to the power 0 as 0, x3 to the power 0 as a 0. So replace all these values here, 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 here and everywhere. Okay, so wherever you will get the this term. Okay, so we can write x1 to the power 1 as a first step. If this one is a 0, this one is a 0, we write x1 to the power 1 as a 17 by 20. 17 by 20. Okay, this one is our first iteration. x2 to the power 1. Okay, this one goes to 0, this one goes to 0, that means minus 18 by 20. And x3 to the power 1. Okay, this one goes to 0, this one goes to 0, that means 25 divided by 20. Okay, now see that these all are the value we got it here. Always remember that guys, find out these answers in a fraction. Okay, fractional value. So what happen, fractional value, it is easier to guess which one is the close and which one is not. Okay, so x1 to the power 1 is a 17 by 20. That means if you use calci, you will get the 0.85 their division. Okay, next x1 to the power x2 to the power 1. Okay, so we get the minus 0.9. Okay, use the calci for finding this calculation. And next x3 to the power 1. Okay, we get the 1 by 25. So you can see guys, these are having a lot of difference between them. Okay, so we cannot say the first is a 0, next one is 0, so lot of big difference here. So we have to find out the further more iteration, so until we get equivalent iteration. Okay, now see that guys, this one is our second iteration. Second iteration says that find out x1 to the power 2, x2 to the power 2, x3 to the power 2. Okay, so these are all values we want here. Okay, x1 to the power 2, x2 to the power 2, x3 to the power 2. Okay, so using x1 to the power 1, x2 to the power 1 and x3 to the power 1. So here we are going to replace the values. I'm going to replace 0 as 1 over here everywhere. Okay, so see that 1 by 20 under bracket 17 minus, okay, 1 by 20 under bracket 17 minus x2 to the power 1 plus 2 times x3 to the power 1. Okay, bracket complete. Again 1 by 20 under bracket x3 to the power 1. Okay, so I'm going to replace 0 as 1 everywhere. Okay, this one is our second iteration. x3 to the power 1 minus 3x1 to the power 1 minus 18. Okay, yes, after that 1 by 20 under bracket 25 minus 2 times x1 to the power 1 plus 3 times x2 to the power 1. Okay, now see that we want the second iteration as x1 to the power 2, x2 to the power 2 and x3 to the power 2. Okay, so replace x1 to the power 1 over here, x1 to the power 1 here, x2 to the power 1 here, x3 to the power 1 everywhere. Replace all the values. Okay, and find out the directly answers. Okay, find out the calculation. Okay, I'm going to write directly the values here. Okay, because it is just a substitution. Okay, it is just a substitution, so I'm not going to find out the further values. So x2 to the power 1, you can take it from here as a minus 0.9. Okay, x3 to the power 1 as a 1.25. Replace here. Similarly, replace x3 to the power 1, this one here, x1 to the power 1 here, okay, and x1 to the power 1 here, and x2 to the power 1 here. Replace all this value here, use your calculation and find out the x1 to the power 2, x2 to the power 2, and x3 to the power 2. Okay, so as I have found these values already, let me write this value. X1 to the power 2, so x1 to the power 2 expected value as 1.02. okay, x2 to the power 2, the expected value for x2 to the power 2 is a minus 0.965 and 0.965, and x3 to the power 2, okay, x3 to the power 2 is a 1.1515. Okay, these are the three values we have here. Okay, x1 to the power 2, x2 to the power 2, and x3 to the power 2. Okay, this one is our second iteration. Yes, now see that guys, the iteration we have here 0.85 and 1.02, minus 0.9, minus 0.965, and 1.25 and 1.50. These are having little difference or a gap between them. Okay, so that we have to take some more iterations. Okay, so that we can get these values are close to each other. Okay, so let's go for the third iteration. See guys, here I written third iteration. Okay, third iteration means the value it goes to the power 2, and we will get the x1 to the power 3, x2 to the power 3, and x3 to the power 3. Okay, so remaining value you must have to replace here. Okay, as we have x1, x2 to the power 2, x3 to the power 2, and x1 to the power 2, replace all these values over here. Okay, and find out the iteration. So I already found the values, I'm going to write the iteration directly. So these are the three values after replacing the values here, x2, x3. So you will get the x1 to the power 3 as this value 1.0134, x2 to the power 3 as a minus 0.9954. okay, minus 0.9954, and x3 to the power 3 as a 1.0032. okay, these are the three values from our third iteration. Okay, so now see that our previous iteration and this iteration having a lot of difference. Okay, so let's go for one more fourth iteration and we'll observe which are the closest value. Okay, so that we consider our final solution for our linear equation. Okay, yes, now next fourth iteration, we go for the fourth iteration. Okay, so what is the fourth iteration? Says that take x1 to the power 4. Okay, x1 to the power 4, again x2 to the power 4, again x3 to the power 4. Okay, and we write this one as 1 by 20, 17 minus x2 to the power 3, x2 to the power 3. Okay, so second you have to take as the value 3. Okay, so how I'm going to write this one as? So see that guys, I written these values here. Okay, x1 to the power 4 as 1 by 20 into 17 minus x2 to the power 3 plus 2x2 to the power 3. Okay, just need to replace 2 as a 3 over here. Okay, so you'll get the fourth iteration. So now see that x2 to the power 3, you replace this value, x3 to the power 3, replace it here, x1 to the power 3, replace here, or replace all these values, find out the answer. You will get the x1 to the power 4, x2 to the power 4, and x3 to the power 4. So see that I found these values here. Okay, so if you want, you can use the calculation, replace the value, find out the answer. Okay, now see that. So how we can judge last answers? Okay, how can we consider last answer here? Okay, now see that these are the fractional values quite closer to each other. So easily we can say that if the values are close or equivalent to each other, we say that the closest values are the solution for our given equation. Okay, now see that x1 to the power 3 as a 1.0134. okay, and x1 to the power 4 as a 1.009. This one is very much closer to each other. Okay, that means we have the closest value. Okay, we have the closest value is a 1. Okay, these are the closest. Now they are the equivalent value, and the closest equivalent value I consider as a x1 as a 1. Okay, now see that x2 to the power 3 as a 0.9954, x2 to the power 4 as a minus 1.0018. okay, so now see that 0.994 means around like a minus 1, and this one is also minus 1, so I consider x2 as a minus 1. Okay, and x3 to the power 3 as a 1.003, 2 and x3 to the power 4 as 0.999. Okay, 0.999 means it's like around 1, and x3 to the power 3 as 1.0032. Okay, now we can see that these are the way close to each other, so we consider x3 as a 1. Okay, now see that I got the value x1 is 1, x2 is minus 1, and x3 is a 1. Okay, it is a required x1, x2, x3 is the solution for our given linear equation in a 3 variable using Jacobi iteration method. Okay, I hope you all have understood. This one is our first solution, x1, x2 and x3. Okay, second and third, x1, x2, x3. I hope you all have understood this one. So for your reference, you can note it down the example. So if you want the point, you can take this one here, note it down, prepare it for your exam, guys. This one is very much important example or method also. Okay, so if the values are other than this, you can deal it very easily. Okay, so not that difficult. I hope you all have understood here my today's lecture. It's completely based on the Jacobi iteration method. Okay, so even after, if you found anything difficult, confusing, challenging, or you did not understand anything, let me know in my comment section, guys. I will come up with a similar videos. Okay, so I hope you all have understood everything. So thank you everyone. Thank you for my today's lecture.